Our sun, a magnificent celestial body that has fascinated humanity for millennia. From ancient civilizations that worshipped it as a god, to modern scientists who study its every move, the sun has always been at the center of our attention. A blazing ball of plasma that dominates our sky. Its surface is a seething, boiling mass of energy, constantly in motion, with solar flares and sunspots marking its turbulent activity. These solar flares can release as much energy as billions of atomic bombs. It is the ultimate source of energy for life on Earth. Without the sun, our planet would be a frozen, lifeless rock drifting through space. The energy from the sun drives our weather systems, powers photosynthesis in plants, and provides the warmth necessary for life to thrive. It provides the light and warmth that we need to survive. Imagine a world without sunlight. No blue skies, no green forests, no life as we know it. The sun's rays penetrate our atmosphere, bringing light to our days and influencing our moods and activities. But have you ever wondered what lies at the heart of our nearest star? What secrets does it hold? The sun is not just a simple ball of fire, it is a complex and dynamic system with layers and processes that are still not fully understood. What makes it burn so brightly? The answer lies in the core of the sun, where temperatures reach an astonishing 15 million degrees Celsius. Here, hydrogen atoms are fused together to form helium in a process known as nuclear fusion. The sun is not a giant campfire in space. It is a massive nuclear reactor, converting matter into energy through fusion. This process releases an immense amount of energy, which then travels outward through the layers of the sun and eventually reaches us as sunlight. It doesn't burn with chemical flames like we see on Earth. Instead, the sun's energy comes from the fusion of hydrogen atoms, a process that has been powering it for billions of years and will continue to do so for billions more. Instead, it's powered by something far more powerful, far more fundamental: nuclear fusion. This process not only powers the sun but also provides the energy that fuels the stars throughout the universe. It is the engine of the cosmos, driving the life cycles of stars and the evolution of galaxies. And this incredible process happens in the core of the sun. Here, under immense pressure and temperature, hydrogen nuclei collide and fuse, releasing energy that eventually makes its way to the surface and radiates out into space, reaching us as the sunlight that warms our days and sustains life on Earth. Imagine taking a journey to the center of the sun. As you descend, you would be met with temperatures and pressures unlike anything on Earth. The sun is made up of layers, each with its own unique characteristics. You would pass through the outer layers, the photosphere with its sunspots, and the chromosphere with its fiery prominences. But your destination lies further in, past the convective zone, where heat churns like boiling water. Finally, you would reach the core. The core is the very heart of the sun. It's here, in this dense and scorching furnace, that the sun's energy is generated. The core is a sphere of plasma, a state of matter where electrons are stripped from atoms, creating a sea of electrically charged particles. The immense pressure of the sun's outer layers pushing down on the core creates conditions unlike anywhere else. It's this intense pressure and heat that make nuclear fusion possible. Nuclear fusion is the process of combining or fusing atomic nuclei to create heavier elements. In the sun's core, hydrogen atoms, the lightest of all elements, are forced together under unimaginable pressure. This forces them to overcome their natural repulsion and merge, creating helium and releasing a tremendous amount of energy. This energy, initially in the form of gamma rays, then begins a long journey outward, eventually escaping the sun as the light and heat we experience here on Earth. Section 5. A toasty 27 million degrees. Just how hot does it get in the sun's core? The sun, our very own star, is a massive ball of burning gases, primarily hydrogen and helium. At its core, where nuclear fusion occurs, the temperatures soar to unimaginable levels. Hold on to your hats because the temperature here reaches a mind-boggling 27 million degrees Fahrenheit. This is the result of hydrogen atoms fusing together to form helium, releasing an enormous amount of energy in the process. That's over 15 million degrees Celsius. To put this into perspective, the surface of the sun, which is already incredibly hot, is only about 10,000 degrees Fahrenheit, or around 5,500 degrees Celsius. To put that into perspective, the hottest lava on Earth is a mere 2,000 degrees Fahrenheit. Imagine the difference. The sun's core is over 13,000 times hotter than the hottest lava flow on our planet. This incredible heat is a testament to the sheer power of nuclear fusion. In the sun's core, nuclear fusion reactions convert hydrogen into helium, producing the energy that powers the sun and emits light and heat. It's hard to fathom such temperatures, but they are essential for the sun to continue shining and providing for our planet. Without this intense heat and the energy it produces, life on Earth would not be possible. The sun's energy drives our climate, weather, and supports nearly all life forms through the process of photosynthesis. So, next time you feel the warmth of the sun on your skin, remember the incredible journey that energy has taken from the core of our star to reach you. Section 6. From core to corona, a temperature tale. While the core holds the record for the highest temperature, the sun's outer layers are surprisingly cooler. The sun's surface, known as the photosphere, has a relatively mild temperature of around 10,000 degrees Fahrenheit. Even more intriguing is the sun's corona, the outermost layer visible during a solar eclipse. This wispy halo can reach millions of degrees hotter than the photosphere. Scientists are still puzzled by this coronal heating problem, trying to understand how the corona gets so hot. Section 7. The Sun's Energy Odyssey. The energy produced in the sun's core doesn't just magically appear in our skies, it begins its life in the core where nuclear fusion occurs. Here, hydrogen atoms are fused together to form helium, releasing an immense amount of energy in the process. This energy embarks on an incredible journey, traveling through the sun's different layers before escaping into space. The journey is far from straightforward and involves several complex processes. This journey can take hundreds of thousands of years. The energy first travels through the radiative zone, a region where energy is transferred by radiation. In this zone, photons are absorbed and re-emitted by atoms, a process that can take a very long time due to the dense environment. The energy first travels through the radiative zone, where it's constantly absorbed and re-emitted by atoms, slowly making its way outward. This process is incredibly slow, with photons taking thousands of years to pass through this zone. Then it reaches the convective zone, where giant bubbles of plasma carry the energy to the surface, much like a pot of boiling water. In this zone, the energy is transported much more quickly, as the hot plasma rises and cooler plasma sinks, creating a convective motion. Once the energy reaches the surface, it is finally able to escape into space. This energy travels across the vast expanse of space and eventually reaches Earth, providing the light and warmth that sustain life on our planet. The journey of the sun's energy is a testament to the incredible processes that occur within our star. From the core to the surface and finally to Earth, this energy plays a crucial role in maintaining the delicate balance of our ecosystem. The energy from the sun is harnessed by plants through photosynthesis, which forms the basis of the food chain. Without this energy, life as we know it would not exist. In addition to sustaining life, the sun's energy is also harnessed by humans to generate electricity through solar panels. This renewable energy source is becoming increasingly important as we seek to reduce our reliance on fossil fuels. The sun's energy odyssey is a remarkable journey that highlights the interconnectedness of our universe. From the core of the sun to the surface of the Earth, this energy is a vital part of our existence. Section 8. The sun's clock is ticking. The sun, like any star, is not immortal. It has a lifespan, and it's powered by a finite amount of fuel. Don't worry though, it still has about 5 billion years worth of hydrogen left to burn. Once the hydrogen fuel in the core runs out, the sun will go through dramatic changes, expanding into a red giant and eventually shrinking into a white dwarf. But that's a story for another time. Section 9. A glowing farewell. The sun's core is a place of unimaginable power and heat, a cosmic furnace that drives the very existence of our solar system. It's a reminder of the awe-inspiring forces at play in the universe, and it underscores our own dependence on this celestial powerhouse. So the next time you feel the warmth of the sun on your skin, take a moment to appreciate the incredible journey that energy has taken, from the heart of a star millions of miles away, to reach you.